on.
Alright, you guys. As you know, I'm Miss Johnson, and today I'm going to teach you how to add integers. Now, this should be something that you learned last year, but you'll see that you're going to have to know this going forward in math in your future math classes. So Miss Batten thought that it would be a good idea for y'all to have a review. So first we're going to start off by taking out a piece of paper. You can all do that? Alright, and then when you have your paper out, you're going to fold it into threes like this.
This way?
Yes.
Oh, you said 40 like
Hot dog. Oh, hot dog.
that's not even a hot dog.
It's the hamburger.
No, that's not a hamburger either.
Chicken.
Alright, and then you're going to label it KWL at the top. Alright, so for the K, you're going to write down what you know about integers. Huh? Just write down what you know. And then for W, you're going to write down what do you want to know about integers.
Do you write the question first and then write what you know?
No, just write what you know.
Oh, what do you want to say? Write what you
And this is going to be taken up for a grade, so make sure you put forth your best effort.
Yeah, I don't know what I'm doing.
Well, do you know what integers are? Okay, well then write that you want to know what they are.
Then don't write what you know.
write what you can.
Stop being yourself.
Okay. Alright, so what are integers? So, what about -1/2? Is that an integer?
Yes. No, it can't be half. No, it can't
Right.
be seconds.
Yes, it can.
It can be a decimal.
All seventh and eighth graders going to the limo lunch, please come to the front of the building at this time. All seventh and eighth graders going to the limo lunch, please come to the front of the building at this time.
Okay, so yes, integers are whole numbers, positive and negative, but pi can't be an integer, decimals can't be integers, fractions cannot be integers.
I got a question. Are some integers rational?
So decimals can be.
I mean, what?
Rational.
Yes. Alright, so when do you think we use integers?
Everywhere.
No.
Like?
During, I don't know. Using within money, I guess.
That's right, with money. Temperature, yes, we use it when we calculate the temperature.
Like in a submarine, trying to figure out how deep you go and how high you go.
Perfect, that's right.
Math.
Yes. Football, yes, that's perfect. And then, also, does anybody like video games in here? Yeah. So if you want to learn how to program video games, you would have to use integers. Alright, so we're going to learn how to add integers, and we're going to learn how to do it in 3 different ways. We're going to use our color counters that you have on your desk. You can take those out. And we're going to learn how to do it with temperature and the number line. find someone to share with?
I got some from the camo. On the low back.
Find someone to share with.
Brandon, over there, no, over there.
Or somebody could sit in the back.
Man, your face is gonna be X'd out. Okay. I don't want anybody seeing this.
Okay, so your yellow chip is gonna be your positive 1 chip, and your red chip is gonna be your negative 1. Okay, so if you have 1 red chip and 1 yellow chip and you add them together, what do you get?
0.
0, right? And those are your 0 pairs.
Nothing.
And then the same goes for any amount of chips. If you have 8 yellow chips and 8 red chips, what are you going to end up with?
Nothing.
Nothing. That's right. Y'all know this. Okay, but now we're gonna add them where they're not equal. So if you have 4 yellow chips and 3 red chips, 1 positive. And then here they're just replacing it with the numbers. 4 plus negative 3 equals positive 1. Alright, and then here's another example. If you have 5 red negative chips and 3 positive yellow chips, negative 2, that's right. And then here they're just replacing it with the numbers. Negative 5 plus 3, negative 2. Alright. And then you guys know which one's the negative one, the red one? Okay, so what integer represents the number of yellow chips?
Wait, positive?
Positive 5, right? Okay, and then if you have 4 yellow chips and you add the 2 red, what do you end up with?
2 yellow.
2 yellow, that's right. Okay, now who knows this one? Back. Uh-huh.
Alright, so the sum of that be 3, negative 3.
Negative 3. That's right. Alright. Alright, now we're going to learn how to add integers using the thermometer. Okay, and then you all know that if the mercury is towards the bottom, it means it's cold. If it's at the top, it means it's hot. Okay, so we're going to start off with the problem. Alright, so if it's 63 degrees outside, and the high temperature for the day is supposed to be 80 degrees, how many degrees is the temperature going to rise?
27. Whoa. No, 30. Yeah, 27.
27?
Wait, that right or wrong?
That's wrong. Does anybody else know?
34.
I'm gonna guess. Negative 17.
Oh my God.
Huh, but it's getting hotter. The temperature's rising.
C.
See?
Oh, okay.
There we go, we got it. Alright,
What?
so,
Wait, I'm confused. It said it went from 63 to 80.
so it's rising.
Yeah, 67. I thought it said 30 something.
Alright, so now another one. Let's say it's negative 23 degrees. It's negative 23 degrees below 0, and then the temperature rises 10 degrees. What's the temperature going to be?
So you want us to write this on the L?
Huh?
Like you want us to write everything out on the L?
Whatever you learn.
Negative 13.
Negative 13, let's see. That's right. Good job. All right, so here's another one. Let's say it's 32 degrees outside, and if the temperature falls 12 degrees, how cold will it be?
See?
See? 20 degrees. And then one more. All right, so the temperature starts at 12 degrees, and then a cold front comes through and drops the temperature by 20 degrees. What will the temperature be after the cold front? -8? Good job. All right. Now we're going to learn how to add integers using a number line. And we're going to use Bob the hiker here. Okay, so when you use the number line, there's 3 things that you need to know. You need to know where you're going to start from, which direction you're going to face, and how far you need to go. All right, so your starting point is your first number in the equation. And then your direction is going to be determined by the operation symbol. And then how far you need to go or which way you need to walk is determined by the second. All right, and then your last step is where Bob ends up on the number line. Okay, so we have the equation -5 plus 6. So where should Bob start off on the number line?
+1.
Where should he start off?
Oh, so it's -5?
Yes, -5. Good job. Okay, so which direction does he need to face?
Positive.
Positive, sorry. So to the right. All right, and then what should he do next?
Then he should move forward 6 spaces.
Okay, so where does Bob end up?
Me?
Mhm.
So we started.
He started at -5, and then he moved forward 6 spaces to the right.
Oh, right.
On 1?
What?
1. That's right. Okay, so I'm going to hand out a worksheet. Actually, hold on. There's one final question. Okay, so what is 6 plus -9? Huh?
3. I mean -3.
-3? Good job. Okay, so for the worksheet that I'm going to pass out, it's going to have some larger numbers, so you're not going to be able to use your chips for it. So, no. So if you have a problem like that, okay, so if you have a problem like -23 plus 31, you're going to have to know absolute value. So what is the absolute value of -23? 23. And then what is the absolute value of 31? 31. So which number is larger?
31.
31. So in the original problem, 31 is positive. So you know that your answer is going to be positive. And then to get your answer, you're just going to subtract 23 from 31. Which gives you what?
7. I mean, oh, subtracting.
Yes. Subtract, I'm sorry.
8.
8. So we already found out that your answer is going to be positive, so you end up with a positive 8. Does that make sense?
Yes.
All right.